Hey everyone, welcome to TechTalks by EPAM. Thanks for joining today to our Cloud Practice Tech Talk. Let's give a couple of minutes to allow more people to be able to join before we start. Meanwhile, I'd like to invite you to scan the QR code so you can be able to interact with the speakers through Slido by sending in your questions and your comments for the Q&A that we'll be having at the end. So you can see the QR code during the whole presentation, and it's right here, and we'll be right back. Well, once again, thanks for joining our Tech Talk. I want to remember you to scan the QR code to send your questions through Slido for the Q&A that we'll be having at the end. First of all, I'd love to welcome our two brilliant speakers today, Andrian Noga, EPAM Systems Engineering Manager, who will be talking about making cloud-native EPAM Loyalty System and holistic approach to solution refactoring. And Vitaliy Zhhuta, EPAM Systems Architect, who will be talking about AAC patterns and anti-patterns. Andrian and Vitaliy, I want to thank you both for your time and giving us this space to talk and learn about these interesting topics. But before we begin, I'd like to give a small brief about who we are in case you don't know us. EPAM is a global community. We are passionate tech lovers and creative minds who develop complex software products and solutions to our clients. We're not only technology and methodology leaders, but we are also building a company with the best talent in the region. We have a global presence, but like this industry, which is always evolving and fast growing, we as a company want to keep up with the same growth in Latin America. And right now we have presence in Colombia, the Dominican Republic, Peru, Panama, Ecuador, Chile, and Uruguay. As you can see, we are committed to build the best engineering company in Latin America. And if you're interested in joining, you can explore our open roles scanning the QR code that will be appearing next and applying, or if you know someone who could be a great fit, you can always share it with them too. We have a very fast selection process, and for great professional and personal growth opportunities, we have several benefits, and the best part of all, being part of the best talent in the region. Right now, we are running our hiring sprint from June 20th to July the 8th. We are hiring DevOps, mobile, Java, Python, and Salesforce engineering. And during this sprint, the qualified candidates will receive an offer within 24 hours and a sign-on bonus up to $5,000. So scan the QR code and apply. I also want to invite you to follow us on LinkedIn. You can find us as S4N and keep posted about TechTalks, the events, both webinars and on in-person events, and the open roles inside the company. So if you haven't checked it out recently, please go. I'm sure you'll find great opportunities for you. Without further ado, Andrian, the audience is all yours.
Thank you, Stefania, for so warm greetings and introductions. Hi, colleagues. My name is Adrian. I am System Engineering Manager at EPAM Systems. With EPAM, I'm for 5 years already, and for these 5 years, I'm working with the GCP practice. And today I want to share with you our journey according to our bringing to our journey to bringing a loyalty customer loyalty system to be cloud native. Uh, Stefania, next slide, please. So our customer, one of our customers, asked us to bring their loyalty system to be able cloud native. First ask from our side, it was, what do you mean about cloud native? Oh, okay, we have a loyalty system that is up and running on our on-prem environment, but we plan to go into the cloud. The next question was, okay, do you have some particular cloud that you want to bring this system up, or do you just want to be a cloud native? And the answer was like, yeah, we choose the GCP as a main cloud, but probably in the future, this system should be a multi-cloud. So based on these requirements and the purpose that we understand, it was like that, and we understand that this system should be able to calculate the bonuses from the customer network. And these bonuses should be quickly changed to some goods or some additional sales or some additional rewards from the network, customer network. The system should be scalable. For example, if it's a Black Friday, so the amount of customers is growing significantly, and the system should be stable. Or then the system should be moving faster and be working faster to calculate the bonuses than it's on-prem. System should be quickly spinning out of the box to be able like provide any changes, and the system should be easy to integrate. And next slide, please. Stefania, next slide, please. Yeah, thank you. Yeah, go to previous slide. Thank you. So the system that customer was owning was composed with the two components. First of all, it was like transaction processing, and second one, there were some design components. The system was built on microservices based on some legacy code, and this system was not scalable because this transaction processing, it was the single point of failure. So it was designed. It was no service discovery. It was the transaction history was stored or RDBMS, and everything was built and it was maintained on-prem. Next slide, please. Could you please go to the next slide, Stefani? Yeah, thank you. How it was done from the EPAM side and from the GCP practice. First of all, it was 4 phases of this journey. First phase, it was assessment. During the assessment phase, we were trying to understand the main concept of the system, as is what mentioned before, and then it was done a discovery. So the discovery was based on the workshops with the stakeholders. During this discovery phase, we were able to understand the business need. We were able to understand the requirements, and during this discovery phase, we were able to understand the main gaps of the system, and based on the discovery, so we prepared deliverables to the customer. The next phase, after agreeing of the deliverables, it was a planning. During the planning sessions, we were able to discuss main activities with the customer, and main activities, main requirements, and based on that, so we built the work breakdown structure. Then we were able to do a design of the whole system. So it was done like service mapping for all services, that was these microservices that were built by the customer, but we mapped these microservices onto small pieces in GCP to be able build this cloud agnostic system. And based on that, we are able to create POC, and after the POC, we created a minimum available product and show it to the customer. The next phase, it was immigration, these microservices into the GCP services, and compose everything based on the network security, customer needs, migration of the users, migration of the data into the GCP. And fourth phase, it was optimization. Optimizations for the customer, what it doesn't means, it was like providing clear support or straight support to the customer based on the customer needs, based on the customer huge optimization strategy. And enhancements, it means thus the improving of the features of the loyalty system itself. Next slide, please. What was done? First of all, all microservices were replaced with the App Engine services, because all microservices were based on Java. So we refactor a bit the code, and we move everything into the App Engine. So the transaction processing architecture, or this microservice, that was a single point of failure. So we migrate into the message bus architecture based on PubSub. For transaction history, we replaced RDMBS into the cloud data store. And for the data storage, we used Cloud SQL. Next slide, please. As was mentioned by me already, so transaction processing was a single point of failure. It was no service discovery at all, and scaling of the microservice was not possible. For example, if the amount of transaction was growing rapidly, so it was not able to scale this microservice. Next slide, please. How we achieve and what was done with the app engines. With the app engines, we delivered solution that was based on app engine services, and even processing services was replaced by transaction process. So even processing service was replaced this transaction processing service. As a backend technologies, it was Java 8, as I said already, and all these microservices were run on App Engine. So we use service replica pool for this, for event processing, and for service, we also used service replica pools for bank service to collecting the data. This, let's say, bonuses. And point bands, also we create an accumulator for pushing data. Next slide, please. The message bus architecture was replaced with the PubSub. Stefania, next slide, please. So we create an event queue for Cloud PubSub, and existing architecture changed to message bus architecture. And this approach is not requiring service discovery. And this approach so PubSub approach based on GCP is making quick or rapid scaling for every independent service itself. Next slide, please. When we are speaking according to the databases, the databases, the MBS database was replaced with the Cloud Data Store and Cloud SQL. This give us, so Cloud SQL service with Postgres engine was chosen as a data storage. And for transaction history, we proposed Cloud Data Store managed service. Next slide, please. Yeah, as it was mentioned before, so here is the architecture design of the database services. And on the last slide, Stefania, could you please jump into the last slide? Here is the detailed transaction architecture diagram. How the all flows, like write-only operations, read-only operations are working with. So it's mean that we have some external query sources like applications, users, retails, mobile devices, and how the system itself is working based on the Cloud PubSub topics, based on the App Engine application pools, based on the compute engine instances where some logic were implemented. If you will have any questions, colleagues, according to the architecture, I will happy to explain more details in questions and answer sessions. Thank you, Stefania.
Thank you, Adrian, for the information. It was really amazing. Now we're going to Vitaliy Zhhuta, EPAM Systems Architect, who will be talking to us about AAC parents and anti-parents.
Hello, my name is Vitaliy, and I'm System Architect at EPAM. I've been with EPAM more than 6 years. On the role of System Architect is almost 5 years, and primarily I concentrated on a different task regarding the infrastructure, building different solutions on the clouds, and yeah, I've been like more than a decade in the cloud development and cloud operation. To those who are familiar with the topic of infrastructure as a code, would be some kind of surprise speaking about anti-patterns, why they exist with these things, but let's see. I will try to explain where those things exist here. Next slide. Before we actually jump to the patterns description, let's figure out that what is the anti-pattern. Anti-pattern, in our understanding, I mean IT guys, is insufficient, ineffective, counterproductive solution. When we speak about the general programming languages like Java, Python, or any other languages, we avoid of using anti-patterns. We try to use patterns. Why? Because it's actually in our nature, I mean, of the human, and it's in nature. If we take a look on those pictures that I presented on this slide, seashell, the plant, the galaxy, they have something in common. And I believe the very first person who discovered what is in common, maybe the Archimedes wasn't familiar with the space at that time and the galaxies, but he saw the seashells and the plants and figure out that those things has something in common. And this thing is actually the Archimedes spiral. It could be drawn and actually could be described with the formula. And that actually, when we try to describe something with the formula or equation, it's actually the very first thing when we describing something with, let's call it a code, with some language that could be repeated in the future. Next slide. I'm trying to bring this example of different equations, but all of those equations are talking about the same things. I guess you all are familiar with the very fast formula that describes the path that will be passed by the car or any particle with a specific velocity with some period of time. Next formula is a bit complicated. Why it's complicated? Because here the velocity could be changed during different times. We can drive car with a different speed, and the path will be different. That one is actually the same equation, but is from the theoretical mechanics, and it's describing the path of the particle in the space. And the last one is the equation of quantum mechanics, also is describing the particle in the quantum space. You see all those equations speaking about the same things. Like how we describe the path of the particle that is moving with some velocity over the time. We can use different things. The same thing could be done when we are describing the infrastructure. We can start simple and complicate it over the time. Next slide. Before we actually jump to the patterns itself, and the transition is maybe not clear, I also would like to get into your mind that we human try to mimic some that we see in the nature and try to apply this to some different approaches in IT. On the right, you see the file system. On the left, you see the tree. What is in the common? The file system, Unix file system, has a root, has the folders, subfolders. Tree has roots, trunk, and branch sub-branches. That is the same as we think about the file system and the structure of the folders and subfolders files. Also, when we speak about the Git and how we're storing the files in the Git and we're choosing the Git strategy, etc., we have those branches, sub-branches, we're merging, moving, creating different branches. We're actually trying to mimic how the nature is working. But yeah, let's stick to the plan and speak about how actually infrastructure as a code can evolutionate into something different and where we actually apply the different patterns. Next slide. I was thinking what could be the most easiest example of infrastructure as a code and the most oldest one. And I actually come up with the idea that etc hosts file that exists on every single file system, and actually right now is more rudimental. We not very often use it, but at the beginning of the internet era, people use etc host to create a map of the IP addresses with the human readable names. Yeah, we know that humans are not good with remembering the numbers, but they are good with the renaming of names. That's why those files appear, and actually people design it, bind the IP address to the name. The problem was that when you added a new host or new hosts appear on the internet, you have to change this etc host file and distribute it about your consumers. And that was causing a problem. People tried to solve this and they come up with the idea of bind server. With the bind server, they created more a tree view, like a tree of the different files, and those files contain the zone, and inside of the zone file, we have the binding of the IP addresses to the names. That we actually get things a bit complicated, yeah, because etc host is flat file, it's easy, but imagine that you are growing the numbers of hosts, and it means that you are growing the numbers of lines in etc hosts. But when you switch to the DNS system, you actually getting the more branched structured of the data. It's getting a bit complicated, but at the same time, it's getting more usable and more easy to maintain. Can we get to the next slide? From my experience, and I would like to bring to you here what I discovered on my experience and how I've evolved over the time with the infrastructure as a code. At the very beginning of my career, I was working for the company that was building private and public cloud, and I was responsible for maintaining the infrastructure. And at the very left side, you see the inventory file that I was used to store the information about the host, and then write some scripts that read information from this file and done some action on the files. You see this file contain maybe human readable, it's easy to read. It contained the information about the IPMI interface, the IP address of the host, and name. Over the time, this file grows, the infrastructure grows. We start to split this into more smaller files that are binded on the groups. And on this slide, you see that it's all the names are like start with a sun, and storage. It's all the hosts are from the storage, but also we have the hypervisors and other systems in environmental running, and somehow we have to distribute. Then we come up with the Ansible. Not we invented the Ansible, but we try to use Ansible and figure out it that fits us and we can solve our problems with Ansible. We actually create a different inventory file, convert our scripts, bar scripts that we have been written into the Ansible roles. Our inventory file become more readable and more structurable with the groups of the hosts, etc. And the process of the configuring infrastructure and maintaining infrastructure become more easy. That was next step. But it could be still infrastructure as a code, but maybe it's not as code as we understand. Why? Because we think that the code needs to have the control flows, like if statements, loops, or something else that controlling how we actually run through the code. Then I would like to bring the example of Vagrant file. Vagrant file use Ruby syntaxes to describe the infrastructure. It's more close to the programming language as we are expecting to see, but it's not so easy to maintain a huge infrastructure with the Vagrant file. And we actually come up to the Terraform. Next slide, please. Terraform. Most used tools nowadays about that we use to describe the infrastructure. It still doesn't have control flows. It's actually declarative language. HCL's HashiCorp configuration language is declarative language. It doesn't has the control flows. We described only the state of the resources that we would like to have. And yeah, but is it possible to have some patterns when we have the declarative language? I believe yes. And why? Because we actually can structure resources in files, in subfiles, folders, subfolders, and actually get something that will be easy to maintain. And actually, we will figure out some patterns here. Next slide. I believe a lot of you are familiar with the approach tree, balcony, and helicopter view. It's actually how we approach any issue, how close we get into the details, how we see the system from different angles. And let's try to apply this to our Terraform code. All of those things will be about the structuring of Terraform resources inside of the files and folders and subfolders. Very primitive, or let's start with this fast layer, tree view. When we have like a small application and we would like to create the infrastructure for this application, we can keep ourselves with a simple one Terraform file, maybe the file with the environment variables, could be like development, quality, production, can imagine what we would like. But all of the resources, configuration of the Terraform can go into the single file. But what if our application will require huge infrastructure? And infrastructure will evolve over the time and get more complex and complex. That means that this file will grow over the time. If we start with a few resources, a few lines of code, at the end it can get us into thousands of resources, thousands of lines of codes, and it's going to be a very hard to maintain. Are you getting this? Like it's like maintaining the etc host file. It's getting complicated. So we actually should invent something that is more easy to maintain. In our case, next step would be to decompose, quantify those resources into the files. We know that our infrastructure requires some compute instances, some database instances, some networking, firewall, maybe some databases, load balancers, maybe some cloud services. So we actually can move all those resources into the files. That get us better maintainability. We get those tree view with those branches, and our branches here will be our files. Easy to maintain, but is it enough? Maybe not. We can go and create the models. And I'm speaking about the Terraform models. And when I speak about the Terraform models, we can think when we have some pattern like free-tier application where we have load balancer, we have the compute and database, and we can put those resources into the single module and reuse. It could be something different. Maybe it's a complex setup of the database or some complex setup of the compute instances. It depends. So we actually can see if it's repeatable and can be reused. We can move it to the Terraform models and it will be much more easy to maintain. Next slide, please. But yeah, that was when we run into the single application. What if we would like to move our application into the several clouds? What if we would like to expand and get our application running in different clouds? So we can create more complex tree structure with the models. That models goes to the different subfolders like AWS models, Azure models, GCP models. We would use the configuration for AWS, Azure, and GCP. It get us more maintainability based on the different clouds. We can separate the duties when we change something to one cloud. We don't infect another cloud. It's a bit different approach. So we can actually separate by the clouds and it's get better. But let's move forward. We actually, in our practice, we are not running the single application. We're running thousands of different applications. Those thousands of different applications requires different infrastructure. Sometimes it could be that some application running on one cloud provider, some application running on a different cloud provider, some application running on Kubernetes, and our infrastructure is getting a really complete mess. And this balcony view is not enough. We understand that we step into the huge enterprise where we have the sound of different business units. Those business units have different tasks. They run different application. This different application requires different infrastructure. Somehow we have to maintain the security. We have to maintain the networking, firewalls, and that's getting bigger and bigger and bigger. So that's, in my opinion, we call helicopter view. And when we try to describe the whole organization from the helicopter view, so we create some folders for the business units. In these folders, we create subfolders. We can create some organization policy constraints. We can create the shells for our business units projects where they run their own infrastructure with their own application, etc. So that's another layer. But where is those patterns here? And here the patterns is first will be how we structure the Terraform code. In our case, I would suggest to structure for the different purpose. And could you switch to the next slide? Yeah. So when we speaking about the one application and infrastructure for one application, we use this pattern that I will call tree view. So Terraform with the several modules, we store this into the single Git repository that is responsible for this application and running the infrastructure for that application. When we have a bit more complicated infrastructure, we can go to the balcony view. We will have a different Git repository where we will structure the project level resources. It could be networking, it could be server YAM configuration, maybe firewall configuration, maybe some resources. Maybe we will run few different application inside of our projects. And the helicopter view, it's when we're trying to describe our organization. And that should go into quite different Git repository. All those Git repositories shouldn't be interfere with each other, because if you are changing on the level of the project, you don't want to affect some security constraints on the organization that can affect the whole your organization. So try to keep all this part in a different Git repository. And yeah, the zone of responsibility. When we are responsible for one application, we go to the tree view and we implement this on the tree view level. When we are responsible for the organization, when we apply like a security constraint policy that can affect every single user in our organization, we have to do this on the different level, on different repository, where we are not touching the project level resources itself, but we setting like a policy that will be applied to the whole organization. Next slide, please. Yeah, but speaking about all those patterns that I explained, it means that we have to write a lot of code. And actually, we with the team come up with the idea. When we managing like a organization and project level, we very often repeat ourselves. We create those shells for the projects, we set the organization constraints, we use the models, but we sometimes simply change the inputs for the models. And when the complexity of our organization getting more and actually really complex, it's really hard to maintain manually this code base. And that's why we invented like Terraform generator, let's call it, or Terraform code builder. So we took this AAC pattern, like imagine that we are provisioning the project for the business unit. So we have to create this shell, we have to bind EAM, we have to create the networking, we have to configure firewall rules, some general stuff. We are not touching the resources that will be consumed by the project, like compute, database, etc. We're just creating the shell for this. And that could be a repeated task. We can create this every day, maybe every week. And if our organization is really huge and there is like 100 or maybe 1,000 of different projects, it's getting hard to keep track and actually changing the variables or copying pasting code from one folder to another and simply changing the input parameters. So we took those Terraform code, convert this into the Jinja template, and create the microservice code that can read the Jinja template, figure out which input parameters are in a Jinja template, and expose these Jinja templates input parameters to the user. Users simply have the interface, they fulfill those parameters, launch, the code builder will take these parameters, generate the Terraform code, store this into the Git repository on very specific approach. I mean, if we were talking about the organization level, it would go to the organization level or project level or application level. It depends where we would like to store this code and which kind of the pattern we're going to apply. Then we can launch the CI/CD process that will take the code from the Git repository, check, test, validate, plan, and apply it to the cloud resource. And I actually have a demo, so I actually can show how this works. Let me share my screen for a while. Okay. Okay, so I have the Git repository that is about the patterns and anti-patterns. I was talking about this user interface where we have the patterns. Here under the patterns, what I understand, so I specified the path where the Terraform file should be put. I specified the commit message, and here about the compute, we have the like disk size, image, machine type, name, server type, subnet type, and team. It's actually all those parameters come from the Jinja. I have same thing for the log sync. So this microservice is actually a Python application. I just launched it for you. It's running. And I created some Postman so I actually show how it works, not through the simply UI interface, but from the post. So we have different endpoints. And if I launch this, I get the modules. You see, I have this packet, compute, logs in, readme, actually a file that exists into the repository where we stored all our templates. So we don't care. Then I can actually get this description of our modules. Here, I guess I should make it a bit bigger. We have our template itself, and the names of these as inputs. So I actually can get info about, and I actually can delete the template. But I will show you the example how I added a new template. I prepared for the demo a Cloud SQL. So I have a Cloud SQL template. As you see, it's a Jinja file, and here, like this will be an input parameter, a name, a tire, the version of my SQL, and so on. So I will take this file. I already prepared just Cloud SQL, and I will choose this file, open, and try to send it. So it get this file uploaded to the microservice. It get the name Cloud SQL and the template itself. So if I just get back to this and try to read all the modules that I has or templates, I will see that new Cloud SQL appear here. And if I try to describe this, I simply change this here and run send. So I will get my template and all of those input parameters. If I go to the UI, here you see we have bucket, compute, logs in, and readme. But let me reload the page, and I get the Cloud SQL. Let's try to fulfill the Cloud SQL. So let's get the path. So I will take this repository. So I'm going to copy the HTTPS copy, going back here, pass, then 2 slashes, and Cloud SQL TF. Commit message, maybe it could be a ticket number, Cloud 11, and Cloud SQL instance. Disk size like 10. Here will be a true. US East 1. Name my family name. Tier something. Just for testing purpose. Version MySQL 8, and the zone US East 1A, and try to submit it. So I actually get a new branch created and created a new pull request. So if I go here, I go to that my Git repository, and actually, if I go, I will see the file has been generated. If we compare what we have seen here, like all those names, etc., that was as a variables, now became fulfilled, and this is ready file for execute. So I can actually get back and match this request, and as soon as like it will be a CI/CD pipeline configured for this, it will, after the match, it will pick up the changes and apply those resources. We actually thinking about the outsourcing this solution into the wide, but haven't decided and maybe not completed. It's right now it's more like POC or maybe MVP. That's actually all. Thank you that you listened to my presentation. I would appreciate if you ask any question and I will try to answer them. Thank you.
Thank you, Vitaliy, and thank you, Adrian, both. We do have two questions. Let me put them here. The first one will be, how does EPAM work with the GCP certifications for employees?
Probably I will ask this question. EPAM is totally support our employees with they willing with certifications. We have a lot of programs inside in EPAM with mentoring, with sharing knowledge between the people who are willing to be certificated, and with the people who are who passed the certification already. So the EPAM is fully supported to those employees.
Okay, thanks. And the other question is, how is EPAM supporting employees that have different professional certifications in the background?
Let me answer these questions too. The certification itself is mostly providing the information in the tech in head by technical people. And for example, we have a lot of people who are certificate not only with GCP but also with Azure, also with AWS, and we are supporting these people because we are bringing these people. We knowing that we know that those people are professionals in few areas, and we are bringing such people into the pre-sales with the customers. We are bringing such people in some technical discussions, and when we need some technical advice, we are trying to engage such people to provide us more professional suggestions in our cases.
Okay, thank you. Another question is anti-patterns a must-know for DevOps and architects at EPAM, or everyone should know about it?
About the patterns or anti-patterns? If we speak about the anti-patterns,
The anti-pattern, yeah.
I guess everyone who faced some difficulties with configuring something or writing could treat this as anti-pattern and don't use it. It's not about you should know everything, every single anti-pattern, but it's like, as I start with the very first slide, it's insufficient, ineffective, and counterproductive. That's if you treat it on your own. If it's not fit your constraints, it should be treated as anti-pattern.
Okay, well, thank you, Vitaliy. We have another one. How can we build data solutions focusing in provide data as a service?
Good question. To be frank, GCP, Google Cloud Platform, as itself, is providing the data solutions out of the box. So if you plan to build some data solution for your company or for your needs, everyone knows it that the leader or pioneer on this area is GCP. So you can use a lot of patterns from the GCP itself, like from the from scratch, and you can build anything you need for data in this case.
Okay. Well, thank you very much. And thanks to both of you, Adrian and Vitaliy, for your time and all the information that you share with us today. I also want to thank everyone else who joined. Please remember that we are running right now our hiring sprint from June 20th to July the 8th. We are hiring DevOps, mobile, Java, Python, and Salesforce engineers. And during this sprint, the qualified candidates will receive an offer within 24 hours and a signing bonus up to $5,000. So please scan the QR code or follow us on LinkedIn and apply. Hope to see you again in our next section of the Tech Talks by EPAM. Stay tuned and have a good night.